Welcome, everyone. Today, we're diving into what I consider one of the most important and most overlooked infrastructure problems in the history of AI development. Before we talk about MCP, the Model Context Protocol, we need to understand the chaos it was built to replace. Imagine you're an engineering team. You have multiple AI models. Maybe you're using Claude for analysis, GPT-4 for customer chat, Gemini for summarization. And you need each of them to connect to your tools. GitHub, Slack, your database, Jira, Salesforce. Here's the problem. Every single combination of model and tool required its own custom integration, its own authentication logic, its own schema definitions, its own error handling, its own maintenance burden. This is the N times M problem. N models, M tools, N times M custom connectors. By the end of this episode, you'll understand exactly why this problem broke at scale and why a protocol level solution was the only way out. Let's get into it. Let's set the scene. It's 2023. LLMs have crossed a capability threshold that genuinely surprised everyone. These models could write production ready code. They could reason through multi step problems. They could analyze documents, summarize meetings, and explain their own decision making. The intelligence was absolutely there. But here's the thing, the intelligence meant nothing if it was isolated. These models lived in a box. They had no access to your GitHub repos. They couldn't read your Slack messages from last week. They couldn't query your Postgres database to answer what was last month's revenue. They were like a brilliant consultant who was flown in and immediately locked in a room with no Wi Fi, no files, and no access to any of your actual systems. The capability was there, the connectivity wasn't. And the way engineers tried to solve this connectivity problem, that's where things got really messy. All right, let's make this concrete with numbers. Because nothing illustrates the scale of this problem better than the actual math. Let's say you're a mid sized engineering team. You have 5 AI models in use. Maybe Claude for code review, GPT-4 for customer support, Gemini for internal search, Mistral for drafting, Llama for local processing. And you need each of them to talk to 10 tools: GitHub, Slack, Postgres, Jira, Salesforce, Notion, Gmail, AWS, Stripe, and Figma. 5 models, 10 tools. That's not 15 integrations, that's 50 custom integrations, each one with its own authentication flow, its own schema mapping, its own error handling, its own maintenance cycle. And every time GitHub updates their API, you fix it in potentially 5 different connectors. Now flip to MCP, same 5 models, same 10 tools. But with MCP, every tool builds one server, every model builds one client, 5 plus 10. 15 total implementations. The complexity drops from n times m, which scales multiplicatively, to n plus m, which scales linearly. That's not a marginal improvement. That's a fundamentally different equation. And as we'll see, the real world pain was even worse than the math suggests. Take a good look at this diagram. This is the pre-MCP world. On the left, you've got your AI models: Claude, GPT-4, Gemini, Mistral, Llama. On the right, your tools: GitHub, Slack, Postgres, Jira, Salesforce, Notion. And connecting them, every single line you see is a separate, custom built integration, each one written by a different engineer, each one with its own authentication mechanism, each one with its own data format assumptions, each one that could break independently when either side updated. This is what developers were actually dealing with, and this is just with 5 models and 6 tools, 30 connections. Scale this to a real enterprise with 10 models and 20 tools, you're looking at 200 custom integrations. 200. And here's the thing that really kills you. When Slack changes their API, you don't fix one connector. You fix 5, one for each model. When you add a new AI model to your stack, you don't write one integration. You write 20. Every new model multiplied your tool maintenance burden. Every new tool multiplied your model maintenance burden. The engineering cost grew faster than the value. That's why teams were giving up. Let's break down what this integration chaos actually cost engineering teams. Beyond just the raw number of connectors, there were 4 specific taxes every team was paying. First, authentication hell. Every single connector had its own authentication implementation. Auth here, API keys there, custom token refresh logic everywhere. Engineers were solving the same auth problems over and over in slightly different ways for each combination of model and tool. Second, schema drift. This one was sneaky and painful. External API change. GitHub adds a new field. Jira deprecates an endpoint. Slack restructures their event payload. When that happened, your integration broke, often silently. You'd find out when a user complained, not when the code broke. Third, glue code tax. A huge percentage of engineering hours was going into pure infrastructure overhead, writing the same mapping logic, the same retry handlers, the same error normalization for every integration. None of this was product work. None of it moved the needle for users. It was just the cost of keeping the lights on. And fourth, version rot. Custom connectors aged terribly. A connector built 6 months ago was often running against a deprecated API version with no documentation maintained by someone who'd since left the team. Organizations weren't abandoning AI because the models were bad. They were abandoning AI projects because this integration tax was killing momentum. The industry didn't sit still in the face of this problem. There were attempts to fix it, but every attempt fell short. In 2022, the approach was raw API calls. You just wrote custom REST integrations for every model tool pair, brittle, non reusable, but it worked until it didn't. In early 2023, OpenAI launched function calling, what they sometimes called tool use. It was a genuinely smart idea. Give the model a structured way to invoke external functions. The problem? Every AI vendor implemented it differently. OpenAI had one format, Anthropic had their own, Google did it differently. If you built for one model, it didn't port. Then came ChatGPT plugins in late 2023. This looked promising at first, a marketplace of tools that ChatGPT could call. But it was completely vendor locked. It only worked inside ChatGPT. The moment you wanted to switch models or use a different AI system, your plugins were useless. The fragmentation actually got worse. Each of these was a band aid on a problem that needed surgery. The root issue was never addressed. There was no shared protocol. Every vendor was inventing their own wheel. And that's exactly what led Anthropic to build MCP in November 2024. Not just another tool calling format, but an open vendor neutral protocol that the entire industry could build on. Here's the analogy that really makes this click, and it's the one that went viral in the developer community. Think about cables. 10 years ago, you had a drawer full of charging cables, micro USB for your Android phone, Lightning for your iPhone, mini USB for your camera, proprietary barrel connectors for your laptop, a 30-pin dock connector for your old iPod. Every single device had its own format, its own charging spec, its own adapter. It was absurd. And yet, for years, the industry accepted it as normal. Then USB-C happened. One port, one cable, works with your laptop, your phone, your monitor, your headphones, your external SSD. The hardware world finally agreed on a contract, and overnight the drawer of cables became almost irrelevant. MCP is that moment for AI. Before MCP, every AI model had its own way of connecting to external tools: custom format, custom schema, custom auth, the AI equivalent of that drawer full of cables. MCP says, here is the contract. If you're a tool, implement this server spec once. If you're an AI model, implement this client spec once, and everything just works together. One protocol, every model, every tool. That's the insight, and it's simple enough to fit on a USB-C port. Now let's look at what MCP actually replaced that spaghetti with. This is the hub and spoke architecture that MCP enables, and I want you to really appreciate the difference compared to what we saw 2 slides ago. On the left, your AI models, Claude, GPT-4, Gemini, Mistral, Llama. They each implement the MCP client spec once. That's it. On the right, your tools, GitHub, Slack, Postgres, Jira, Salesforce, Notion. They each implement an MCP server once. That's it. In the middle, the MCP protocol layer, a shared contract that both sides agree to. Every line you see here is not a custom integration, it's a protocol compliant connection. When GitHub updates their API, they update their MCP server. Every model that's connected gets the update automatically because they're all speaking the same protocol. When you add a new AI model to your stack, it doesn't need to negotiate with each tool. It connects to the MCP layer and gains access to everything that's already there. This is what n plus m looks like instead of n times m. Clean, scalable, composable. And the protocol itself? It's built on JSONRPC with three core primitives: tools for executable actions, resources for read-only data access, and prompts for reusable workflow templates. But we'll go deeper on those in a future episode. For now, just appreciate how different this is from the chaos we just walked through. Alright, so now you know why MCP was needed. Let me give you a quick look at how it works, just enough to appreciate the elegance. MCP exposes three core primitives, three things that a server can offer to any connected AI model. First, tools. These are executable actions. Think, run this SQL query, send this Slack message, create this GitHub issue, trigger this workflow. Tools are how AI models take action in the real world. They're the hands. Second, resources. These are read-only data sources. Think, read this file, fetch this document, get the database schema, browse this directory. Resources give AI models context, real-time information they can reason over. They're the eyes. Third, prompts. These are reusable workflow templates exposed by the server. Think, a standard code review prompt, an incident response template, a PR summary format. Prompts let you standardize how the AI interacts with a tool, not just what it can do, but how it should approach doing it. And here's the beautiful part. All three run over a single stateful JSON RPC session. One connection, one protocol, access to everything a server exposes. This is what makes MCP so much more than just another tool calling format. It's a complete interaction model, actions, context, and workflow templates, all standardized in one contract. Numbers don't lie. Let's look at what happened once MCP was out in the world. Anthropic launched MCP in November 2024, quietly, as an open source release. Downloads in that first month? Around 100,000. Respectable for a new protocol, but nothing earth shattering. Then the flywheel started. By March 2025, just 4 months later, OpenAI adopted it across ChatGPT Desktop, their agents SDK, and the responses API. Sam Altman publicly said, "People love MCP, and we are excited to add support across our products." That's a competitor endorsing a rival's protocol. That almost never happens. Google DeepMind followed in April. Microsoft Copilot Studio added support. AWS integrated it in July. Fast forward to November 2025, 97 million monthly SDK downloads. That's not hobbyist traffic, that's production adoption. By December 2025, Anthropic donated MCP to the Linux Foundation. It became a vendor-neutral industry standard, co-governed by Block, OpenAI, and backed by AWS, Google, Microsoft, Salesforce, and Snowflake. By Q1 2026, over 17,000 public MCP servers indexed. In 18 months, MCP went from a quiet open source release to the foundational infrastructure for how AI connects to the real world. The N times M problem that broke teams for years, solved. All right, let's land the plane. We've covered a lot of ground in this episode. The N times M problem, the spaghetti architecture, the stopgap era of function calling and plugins, the USB-C moment, the hub and spoke architecture MCP enables, and the staggering adoption proof. Let me leave you with three things that actually matter for your work. 1. Stop writing glue code. If your team is still building custom connectors between AI models and your internal tools, you are paying an engineering tax that MCP eliminates completely. Find the MCP servers for your tools or build one. It's a one-time investment that serves every model you'll ever use. 2. Think in protocols, not integrations. The mental model shift is simple but profound. Instead of asking, how do I connect Claude to our Postgres database? Ask, does Postgres have an MCP server? One question replaces 50 integration decisions. 3. The platform layer just shifted. MCP is infrastructure, the same way TCP IP is infrastructure or USB-C is infrastructure. The developers and teams who understand this deeply, who build on it now while it's still early, will have a compounding advantage as the agent ecosystem explodes over the next few years. This is not hype. The adoption numbers we just looked at prove it's already happening. In the upcoming episodes, we'll go deep on MCP's actual architecture, hosts, clients, and servers, and how they coordinate to make all of this work under the hood. Subscribe to stay connected. See you in the next one.